Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for today is October 26, 2024, and the time is it's a military time on my digital clock. It's 1:55 a.m. Okay, my topic for this morning will be a long video format topic. Uh, we've been we've been saturated with short videos regarding electronic assembly. So for this morning, I'll go back to my long video format to continue it. And this long video format is actually analytic geometry. This is lesson number 17. We are running smooth. This will be the last topic of the parabola before we will proceed with the next conic section, ellipse. Okay, let's proceed. The title of the subject matter for this morning will be Analytic Geometry, lesson number 17. And this is parabola example problem. This is 3 or number 3. I have given you already 3 example problems after discussing the concepts regarding parabola. I think that's more than good enough to illustrate the concept of a parabola. Okay, let's try to read the problem for this morning. Problem. Find the graph of sorry for this one, it should be plot the graph, not find the graph. Plot the graph. Syntax error. Plot the graph of a parabola. If its equation is given by the equation y equal to x squared minus 6x plus 33. So we are given an equation, and that equation is actually quadratic. So if it's quadratic, it's possible that's a parabola. But for this morning, it is for sure that this equation here is a parabola. The problem is just asking, we'll plot the graph of this equation here, which is a parabola. So how could we prove that the given quadratic equation is a parabola? Okay, let's try to bring out the solution. The solution of this one is actually by using our knowledge of the so-called completing squares under the study of algebra. So, proceeding with the solution, y equal to x squared minus 6x plus 33. I will try to rearrange. I will put the square term on the left, x squared minus 6x, right? And they should be equal to y. This is originally on the right, and if we try to transpose it to the left, it will become negative 33. So after the rearranging, what comes out is x squared minus 6x equal to y. We transpose this to the left and we rearrange, so this is now negative 33. So the resulting equation now will be this. Okay? By using our knowledge of the so-called completing squares, meaning if we try to make the left-hand side a perfect binomial, okay, we will take 1/2 of the coefficient of x. The coefficient of x is actually negative 6. We will take the 1/2 of that, close bracket, and we will square it. Right? So minus 6 over 2 will be negative 3 quantity square. Negative 3 square is actually positive 9. The significance of this 9 here is that if we try to add plus 9 to the left, the resulting left-hand side will be a perfect binomial. Okay? So I will rewrite x squared minus 6x. I will add up 9. This 9 here emanates from this one, right? And this should be equal to y. I'm following this. Minus 33. This is plus 9. Okay, there is a plus 9 here, and there is a plus 9. So actually they cancel out, but we could do it, right? So after adding a plus 9 on the left hand side, like what I said, it's now a perfect binomial. It will now be factorable to the binomial x minus 3 quantity square. Because if we try to expand this one, it will become the square of this one will be the square of the first term, which it will become x squared. The middle term will be negative 3 times x times 2, so it will become negative 6x. And the last part, the pure constant, is actually the square of negative 3, which is plus 9. So this quadratic thing here will be factorable to a perfect binomial, like what I said, x minus 3 quantity square, equal to the right hand side, minus 33 plus 4 will be negative 24. We could enclose this in a quantity. Doesn't matter. And if the resulting equation now, after the manipulation, this is similar to the form x minus h quantity square equal to 4p times the quantity y minus k. This is a positive sign, so I just place the positive sign here. This is plus, so this is understood to be plus, right? So if it's a plus, like what I said, we don't have to put the positive sign. It's understood to be plus. So the resulting equation is similar to this, okay? And this is actually a parabola. Okay? But we must have to identify the location of its vertex. The location of the vertex will be at the location HK. And since this parabola is, because for one value of y, the value of x will be 2. For one value of y, there will be a value for x which is to the left and to the right. So this is a parabola, axis parallel to y-axis. It should be vertical. And since this is plus, of course our parabola will be upwards. So opens upward. Okay, so we identified already the shape of the parabola. We should locate the location of the vertex. Like what I said, for one value of y, there will be two values of x. So this parabola is symmetrical with respect to the y-axis, or the axis of this is vertical, or it's parallel to the y-axis. Okay, and since this is plus, it should open upwards. Okay, let's try to find the location of the vertex. From this, these two equations here are similar, so we could equate x minus 3 to x minus h. So x minus 3 equal to x minus h. Actually, x cancels, right? Negative 3, negative h. We could multiply this by negative 1. So negative 3 times negative 1 will be positive 3, and negative h times negative 1 will be positive h. So the location of h is actually at the location 3. Okay? For the ordinate, we will equate this y minus k to this y minus 24. So y minus 24, because they are similar, right? Equal to y minus k. And this y here cancels. Okay? They are both negative also. So to eliminate that negative thing, we will multiply both sides by negative 1. Negative 24 times negative 1 will be positive 24. Negative k times negative 1 will be positive k. So the ordinate of the vertex will be at the location 24. So I place it here. the vertex designated by capital letter B should be at the location 3 and 24. It should be at this location here. The value of h is actually abscissa and k is actually ordinate. So at the location 3, this is 3, right? 1, 2, 3. And the ordinate will be k, which is 24. This is not drawn to scale. I have, what you call this, I approximated that this location will be 24. So this is the location of the vertex. That's the vertex. Right? And this is a parabola, like what I said, axis parallel to the y-axis and opens apart. So if we try to plot the graph like what the problem is asking for, this should be the graph. We specified the location of the vertex already. The equation of this parabola is this one here. Actually, we could calculate where the parabola intersects the y-axis. We'll just go back to this. When x is equal to 0, okay, what will be y? We could compute for this. We are given the equation. When x is 0, this will become 0. This will become 0 also. Right? So the value of y is 33. So the location of the y-intercept is actually at the location 0 and 33. So the parabola intersects the y-axis at the location 0 and 33. And it should open upward. Okay? So this is the graph of the parabola. As simple as that one. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes. So this will now be the last topic under the parabola under my long video format topic. The next time around, I will try to discuss ellipse. Okay, good morning.